Redox review. To determine the oxidation state of an atom, you look at every bond. This is organic chemistry, people. If you are bonded to a less electronegative atom, you get an oxidation state of -1 because the electrons are closer to you than the other atom. If you are bonded to a more electronegative atom, then the electrons are further from you and closer to the other atom, you get an oxidation state of +1. If you are bonded to an atom with the same electronegativity, you get an oxidation state of 0. Assign an oxidation state for each bond, add them up, you have your answer. This is test 1 review. Okay, so if you're going to do this properly, you better remember where the H's are. So we have a C here with 2 H's. And a C here with 1 H. Oxidation for number 1 is -2. How come? Oops, 1 is -2. It has 2 bonds to less electronegative H and 2 bonds to the same electronegativity C. Atom 2 has 3 bonds to C. You get a 0 and a 0 and a 0. And 1 bond to H, you get a -1 because H is less electronegative. And similarly, putting the H's on over here. Maybe we'll put the answers in red. Give a little contrast. Number 1, don't forget there's an old H on there. Wait, 2 H's. There's a new H on there, sorry. Old H was black. New H is blue, 2 of them. And there's 3 of those things now, right? So number 1 is -3, and you get a 0 for the bond to C. 2, you get a -1 for the bond to H, -1 for this bond, +1 for the bond to the more electronegative O, a 0 and a 0. So overall, -1 + 1, 0, 0 is 0. So atom number 1 went from, we'll do atom number 1 in yellow. What do you call it when you go from -2 to -3? Oxidation or reduction? Reduction. All right, we'll do atom number 2 in baby blue. So 2 goes to 2. What do you call it when you go from -1 to 0? Your oxidation state went up. Oxidation. I'm removing my reduction to make sure it's on the yellow. And oxidation. Okay. Now I'm going to be a little more detailed. What change was the oxidation? +1, +2, +3, the difference from beginning to the end. +1. Up, +1. What about reduction? Down by how much? -1. These cancel. Cancel. Conclusion is, therefore, hydration is not considered redox. Yes, you have an atom that got oxidized and an atom that got reduced. You'd normally think that fits redox. But in the one molecule, they cancel each other. There's no net change in oxidation. Same comment here. Whoa. Copy paste. In this example, the yellow is always from 1 to something. Yellow. I need a yellow. Where's my pen? Yellow 1 goes to 1. It went from -2. Oh, I didn't do the oxidation states. My goodness. Well, when we get an answer for 1, and 1 now is -1. Can you tell me how I did that? Yeah, I got -2 and +1 and 0. So you went from -2 to -1. That one is now an oxidation, correct? It went up. And baby blue is for 2. And it went from, well, 2 is -2, correct? 2 bonds to H, negative, and 0, 0 for carbon. And 2 went from -1 to -2, that's reduction. So you see why I have the same comment for the second reaction as I did on the first? They're both called hydration reactions because you have a new OH and a new H. You want the new H in a different color. On this one, there it is. There's the new H. There's the new OH. That's hydration. Adding water to a formula. Hydration. We got an anti-Markovnikov versus a Markovnikov in terms of redox. Doesn't matter. They're both not redox. That's what it says. Not considered redox. But our next one, which is a new reaction, I believe you're going to have a -2 for 2 and -3. So yellow for 1 went from -2 to -3. You call that reduction. It went down by -1. And in baby blue, for 2, -1 and -2 is also called reduction. Uh-oh. No. 2's got 2 bonds to H, -1, -1, and a 0 and a 0. Yeah. And reduction also by -1. You cannot tell me they cancel. Hydrogenation, which is the name of this reaction. Hydrogenation. Good name, right? It adds hydrogen. You want to see the new hydrogens? They're in black. Oh, we got the new black one there already. It's here. I'll make it more black. Okay. What do you got? Hydrogenation is called a reduction reaction. RXN stands for reaction until the end of Orgo 2. Okay? RXN is the short form for reaction. It's a homonym. Just say RXN real fast. It sounds a lot like reaction. RXN. Sounds like reaction. I like words like that. Okay, so maybe we'll have an oxidation coming soon, and yes, we will. We'll have 2 oxidations in our last video for chapter 6 when we study ozonolysis and vicinal dihydroxylation. Wow. Okay, we're stopping.